Hello friends, in this video we are going to see about the data reduction techniques and how the data reduction can be performed with the data set. The method of data reduction may achieve a condensed description of the original data, which is much smaller in the quantity but keeps the quality of the original data. Data reduction strategies applied on a huge data set, complex data, and a mining on a huge amount of data can take a long time and making such analysis impractical or infeasible. Data reduction techniques can be applied to obtain a reduces data should be more efficient yet produces some analytical results. Some strategies which we applied while performing the data reductions are: first is data cube aggregation. This technique is used to aggregate the data in a simple form. For example, imagine that information you gathered from your analysis for the year of 2012 and 14, that data includes the revenue of your company every 3 months. They involve you in annual sales rather than the quarterly average. So, we can summarize the data in such a way that resulting data summarize the total sales per year instead of per quarter. So it summarizes your data in a quarter manner. Second technique is dimension reduction. Whenever we come across any data which is weakly important, then we use the attribute required for analysis. It reduces the data size as it eliminates the outdated or redundant features. Stepwise forward selection. How we can perform the selection of your data? The selection begins with an empty set of attributes. Later on, we decide best of the original attributes on the set based on the relevant attributes. So, we know it as a p-value in a statistics. Suppose there are the following attributes in the data set in which few attributes are redundant. See, initially the attribute set contains x1, x2, x3, x4, x5 and x6. So we having one data set. In that, first is x1, second is x2, third is x3, fourth is x4, fifth is x5 and x6. Initially, the redundant attribute set is blank. As we are saying that redundant data set is blank. Now what we are doing? Step 1. First we have accepted one first attribute, then we accepted the second attribute, then whichever is the important attribute, then final redundant attribute set is x1, x2 and x5. So we can say our attribute state start from a forward selection always. Next, stepwise backward selection. This selection starts with a set of complete attribute in the original data, and at each point it eliminates the worst remaining attribute in the set. Suppose there are following attribute in the data set in which few attributes are redundant. So how we can do that? See, initially we having same attributes x1, x2, x3, x4 and x5 and x6. And in the redundant attribute also we are putting all the attributes like x1 to x6. Now what we are doing? In the step 1 we are accepting from x1 to x5. We are not accepting the x6 attribute because we feel it is a important attribute. Then we are accepting from x1, x2, x3 and x5 because we are coming from the backward. Next, in the step 3 we are accepting whichever is the important redundant attribute, that is x1, x2 and x5. So now if you say the attribute of redundant set, we contain x1, x2 and x5, but this is using backward selection, not with the help of forward selection. Next, combination of a forward and backward selection is, it allows us to remove the worst and select the best attributes. It also saves your time and make the process faster. Third is data compression. Using data compression, the data compression technique reduces the size of the file using the encoding mechanism like Huffman encoding, Renlen encoding, etc. So we can divide it into the two types based on their compression techniques. First is lossless compression, that is, encoding techniques, run length encoding, allows a simple and a minimum data size reduction. Lossless data compression uses the algorithm to restore the precise original data from the compressed data. Then, in the lossy comparison, we are accepting a discrete wavelength technique, transformation technique, or PCA technique, that is principal component analysis, are the example of this expression. For example, consider we having one JPG image format which is of lossy compression, but we can find the meaning equivalent to the original image. In a lossy data compression, the decompressed data may differ to the original data, but are useful enough to retrieve your information. Means consider we are getting whatever if the data, consider we are getting some JPG image which is not clear to our concept, but at least the information which is given by this image is getting by ourselves. So that is also one of the important compression technique. Fourth technique is numerosity reduction. In numerosity reduction, the actual data is replaced with a mathematical model or a smaller representation of a data instead of the actual data. It is important to only store the model parameter or non-parametric methods such as clustering, histogram, sampling. For more information, we can also go with the numerosity reductions. Fifth is discretization or concept of hierarchical operations. The technique of data discretization are used to divide the attributes of the continuous nature into data with the intervals. We replace many constant values of the attributes by a label of small intervals. This means that mining results are shown in a concise and easily understandable way. Next approach which we are using first is top-down discretization. In top-down discretization, if we first consider one or a couple of points, to divide the whole set of attributes and repeat of this method up to the end, then the process is known as a top-down discretization, that is also called as a splitting of your data, right? Next is bottom-up discretization. If you first consider all the constant value as a split point, some are discarded through a combination of neighborhood values in the interval. That process is called as bottom-up discretization. The concept of hierarchies, it reduces this data size by collecting and then replacing the low-level concept such as 43 for age to high-level concept like categorical data such as middle age or senior age, like that. For numeric data, following technique can be followed, like binding. A binding is very important concept for the decision tree classification. A binding is the process of changing the numerical value into the categorical counterparts. The number of categorical counterparts depend on the number of beans specified by the user. Histogram analysis. Like the process of binding, the histogram is used to partition the value for the attribute x into the disjoint range called as brackets. There are several partition rules. First is equal frequency partition, partitioning the values based on their number of occurrence in the data set. Second is equal width partition, that means partitioning the value in a fixed gap of number of beans. That can be a set of ranges value like 2, 3, 10, 20, etc. Third is clustering, that means grouping the data in a similar manner. So similar data you can cluster in a single data, and that also you can perform. So in this video we have seen what are the different data reduction techniques and as well as how we can apply those techniques in a data set. Thank you.